Transforming data is of course something we could also do here inside of subscribe, and that would generally not be a problem. But it is a good practice to use observable operators because it simply allows us to write cleaner code with different steps we funnel our data through that can easily be swapped or adjusted, so that you have a lean subscribe function here and have other steps that focus on other parts. Therefore, here before we subscribe, we can now call pipe, because pipe, as you learned, is a method that allows you to funnel your observable data through multiple operators before they reach the subscribe method. Now the operator I need here is the map operator, and therefore I will import map from rxjs/operators. The map operator allows us to get some data and return new data, which is then automatically re-wrapped into an observable so that we can still subscribe to it. If it would not be wrapped into an observable again, we could not subscribe. So let's map here. Let's add map as an argument to pipe, and map is a function which we call, and that function now again takes another function as an input, a function which will get our response data, and that should now return the converted response data. And here the idea is that we return an array of posts instead of an object with that cryptic key which then holds our actual post. Now to convert a JavaScript object, which we have here, to an array, we have to manually loop through all the keys and create a new array. So here I'll create a new post array constant, which is empty initially, and then I'll use a for in loop to go through all my keys in response data, which I know will be an object, and then I want to push each piece of data into my posts array. So here I will then use posts array and push response data key. So I'm accessing the key we're currently looking at in response data, and therefore I'm accessing the nested JavaScript object, and I'm pushing that nested JavaScript object into my posts array. However, I don't just want to push that object like this in there. Instead, I want to push a new object in there. So let me add curly braces. And let's use the spread operator now. This will pull out all the key value pairs of that nested object we're accessing here. And let's close this with curly braces too, because this now allows me to also add one new key value pair to that object we're adding to posts array. And that should be an ID field, which actually stores the key. Because that key here, that cryptic string, is a perfect ID, and it is a unique ID generated by Firebase. Therefore, of course, I want to keep that so that we have this, for example, if we wanted to delete a single post or anything like that. So now we're pushing this new object into our posts array here. Now, it is a good practice to wrap this with an if statement if you're using a for in loop, where you check if response data has key as its own property, so that you're not trying to access the property of some prototype. And with that, posts here now really is an array of posts. And now we only need to make sure that we return posts array here in map, so that this is now forwarded to our subscribe function. With that, if that now reloads, indeed here we see we have an array, we have square brackets, and in there we have an element which has a content, the ID we added, and the title. And this is how we use observable operators to transform our data. The next step now, of course, is to output our posts. Before we do that, however, let me bring your attention to a tiny problem we have here, or to a spot where we can improve our code. If we hover over posts here, in your IDE, you probably see the type of posts, and you see that this is of type any. That, of course, means the TypeScript is not able to detect how our posts look like, the format of our posts, because here posts array also is of type any. Because the only thing TypeScript sees is that we add the ID key here, but other than that, the object we push is totally unknown to it because it doesn't know the format of our response data. There it only knows that it's an object, but not how this object looks like. We can tell TypeScript how it looks like. One way of doing it would be to assign a type here on the argument we're getting in map. So we could say, yeah, we know that this actually will be an object, where we have a randomly generated string. And now this syntax can look really weird in TypeScript, but in the end, you use a placeholder property name for that by using square brackets here, and then you add key colon string in there, which simply means this is any string key we have here on that object. We don't know the exact property name because it's randomly generated, or not randomly, but it's generated by Firebase, and we do have many different properties, but we know it will be a property that can be interpreted as a string. And now the value held by that property is our actual post data, right? It's the same format we have here. Now, therefore, to simplify this a bit for us, we can, of course, add a new model, let's say a post model here, where I export an interface, and I'll name this post. And this will just have that format here, title and content. And actually will optionally also have an ID. Let's add a question mark here to make clear that this is a string, but it's optional. And now we can use that here. So there we use post. We just need to import that. So let's import post from our post model file here. So from /post.model. And now we know here we have that randomly generated ID, but that will then hold a post as a value. That's that nested element I showed you in the developer tools earlier. With that now, TypeScript suddenly knows what's inside of response data, and now we can also set the type here on our posts array and say, yeah, that will be a post array, which you set by using this type assignment. The name of the type and then square brackets to indicate that it will be an array of these types. This now is improved code because now we can clearly understand what's inside of posts array, and we get better auto completion. For example, if I try to access the first element, you see I can now access ID, content, and title because I now know that it has this format and that therefore is a recommended practice. However, with the Angular HTTP client, there is a more elegant way of assigning the type. You don't need to do this here on the argument in map or in subscribe or whatever you're using to access your data. Instead, the get method is a so-called generic method. This means you can add angle brackets here, and between the angle brackets, you store the type which this response will actually return as a body once it's done. So it's the response body type which you store here. And that will then automatically be handled by the Angular HTTP client, and TypeScript understands this and now knows that the response data will have this type format, as you can tell. And this is also available on post requests. It's available on all requests. You can use these angle brackets to add this extra piece of information, which is totally optional, but recommended and helpful about the data you're getting back. And now here you know it'll be a JavaScript object where you have a name property, and the value of that will be a string. Because if you remember, when you send a post, this is a new post, really new, the data you get back is exactly such an object, name property, and then a random string. And now we're making this really clear here so that we also notice in our subscribe function, and if we had code that depends on the types, we get better auto completion and avoid unnecessary TypeScript errors. So this is optional but recommended. You can define the response data types here on these generic HTTP verb methods. Let's now output our data now that we're fetching it. For that, when we're getting the data, instead of logging it, since we now transformed this into an array of posts, we can set this loaded posts, which is a property I created earlier, where we now also can be more explicit about the type it will store, because that will be an array of posts, of course. We can set this loaded posts here equal to the posts we fetched. Now we just have to use loaded posts in our template. And for that, of course, in this area where I say no posts available, I only want to say that if we really have no posts. So I'll add ngIf here and check if loaded posts length is smaller than 1, which means we have no posts. If it is longer than 1, then I want to output an unordered list with a class of list group, which is a bootstrap class, which has list items with list group item as a class. And in there, we'll have a h1 tag for the title and a paragraph for the content of the post. Now I want to only show this, of course, and hence I'll add ngIf on the unordered list if loaded post length is greater or equal than 1. So it's the opposite of this condition here. If that's true, we'll show that list. And now I want to loop through all the loaded posts and recreate a list item for every loaded post. So here I'll add ng4 to go through all my posts. So I'll name this post of loaded posts. And then here we can output post title. And for the paragraph, we can output post content. Let's have a look at whether this works. If this now reloads, it fetches the posts, and you see thereafter these posts appear here. Now maybe the heading is a bit big. Let's maybe use h3 here. But the important takeaway is that our data loads, of course. Now that is super awesome. And this shows us how we can make the step from loading the data to outputting it in our front end. We're now outputting our loaded posts. We can refetch them here by clicking fetch, though we of course don't really see a difference here because we fetch the same posts and we have no indicator for whether a request is currently on its way or not whilst we're waiting for the response. Would be nice to have such an indicator. And that can be easily implemented by adding a new property, which you could name isLoading, which initially is false. And you want to set isLoading, or maybe let's name it isFetching because I only want to use it for fetching posts. And you can use isFetching and set it to true whenever you start fetching posts. So here at the beginning of this fetch posts. There, you can set this isFetching to true because now we are starting to fetch posts. And once we're done, so here in the subscribe function, we can set this isFetching back to false. Now what's the advantage of this? Well, we can show a loading indicator whilst we're fetching posts. So back here in our template, we want to show no posts available if we have no posts, and also important, if we're not currently fetching. Because if we are fetching posts, then we want to wait for that result and not show no posts available too early. Of course, we also only want to output posts if we're currently not fetching too. So here, I also will output this only if we have posts and we're not fetching. This, of course, means we have a third scenario now, that we are fetching and we don't care about whether we have posts or not. And for this, you could output simply loading or display a nice CSS spinner if you wanted to by using ngIf equal isFetching. Now, let's have a look at that. Let's reload, and you see loading here. And if I click fetch post again, you see loading. Now, unfortunately, Firebase is really fast, and therefore you only see this for a fraction of a second, but you see it does work. And if you had a slower server, you would of course see it a bit longer.